I think I am live now. Can anyone confirm if audio and everything is fine before we get started for today? Like, I was able to solve all the problems, so naturally I would be discussing all the problems. Okay, it's fine, right? Okay. And people in the chat, like, how many problems were you guys able to solve today? Like, to give me some estimate of like which problems to focus more on. The fourth problem. Okay, I'm also counting these as a problem, by the way. Okay, let's start from the easiest problem first. First problem says athletes of Safland have won G gold medal, S silver medal, and B bronze medals in Paris Olympic. SAF will be happy only if Safland team wins 5 medals of each type. Find the total number of additional medals the team needs to win to make SAF happy. So here, like the idea is like basically we want to win every medal at least 5. So any medal we have more than 5 types, we can ignore that. And for remaining medals, like we should check the difference of it with 5. And that was the idea for this problem. Jumping onto the code for this one, like I just created an array of size 3, read all the 3 numbers, and then took answer of like if x less than, we can probably write it this way. If total medals one of a particular type is less than 5, then x minus 5 would be the more medals we need. And this pretty much solves the problem for, and this was the easiest problem of the contest. And this was my solution for it. And the idea is no winner. Second problem is no winner. After a series of matches between Alice, Bob, and Cameron, their scores are A, B, and C respectively. Seth plans to organize M additional matches, and in each match, 2 players compete, and there is exactly one winner. The winner of the match receives 1 point. Determine if it's possible for at least 2 players to end up with the same score after all M additional points are completed. And like 3 integers are given, and integer M is also given to us. Here the idea would be like probably we can look at like let's say A1 is the score of first person, A2 and A3. And let's probably look at these 2 numbers first. And let's assume that A1 is less than equal to A2. In this case, we have to increase the score of A1 by A2 minus A1. So like this should be at least should be less than equal to M matches. And what we can do is like we can ensure that the third player wins the remaining matches. And this was the idea for this problem. Basically, you fix 2 players you want equal score. You see how many extra scores someone needs to make equal score, and you see whether that count is less than equal to M. If it is less than M, then you say that player would win that match, and another player can win all the remaining matches M minus delta VF. So I ended up sorting the numbers, but that was not required, to be honest. Sorting all the numbers just ensure that maximum minus minimum is not never optimal. So like this would be the score required to make score of 0 and 1 equal. This would be the number of matches required to make 2 and 1 equal. If minimum of these, like the minimum extra matches we need to make at least 2 equal pairs is less than equal to m, print yes, otherwise print no. And this was the solution for the second problem. Knockout matches tournament is a type of elimination tournament where the loser of each match is immediately eliminated from the tournament. The following image showcases a knockout tournament between 16 players. In the tournament, initially 16 players are probably, let me just copy this image and so let's look at see how many players someone is winning. Like the player one who is the eventual winner of the match wins 4 matches here. These. Player 2 wins 0 matches. Player 3 wins 2 matches. Player 4 wins 0 matches. And you can probably see like how many matches someone is winning. P5 is winning 3 matches here. P7 2. P0 and P8 are winning 0 matches. P9 is winning 3 matches. P11 is winning. P11 is winning 2 matches. P12 is winning 0. P10 is winning 0 matches. P P9 wins 4 matches by the way. Basically 1, 2, 3. Wait, probably looks like I'm messing up something here. Okay, P1 1 match, 2, 3, 4, 4 matches. 0, 2, 0, 1. Probably looks like yeah. P3 has won only 1 match. P4 has won 0 matches. P5 has won 2 matches. P6 0. P7 has won only 1 match. P8 has won 0 matches. P9 has won 1, 2, 3 matches. P10 0. P11 2. P12 0. P13 has won 1 and 2 matches. 14 0. 15 1. 16 0. And like this is the count everyone is winning the matches here. And probably let's see like how many matches, like how many people have scored less than P9. Like P9 loses to P1 here. So like definitely P9 skill is less than P1. But you see like P9 skill is more than P13. P13 has more skill than P15. P15 has more skill than P16. Similarly, P13 has more skill than P14 because like higher skill player always wins. P9 won against P11 as well. P11 won against P12 as well. And P9 also won against P10 as well. So you see 1, 2, 3, 4, 5, 6, 7. Like 7 people should have less skill than P9. And in that case, P9 has won 3 matches. And this in general holds true. Like for a person to win 5 matches, let's say in general, we would have a kind of complete binary graph of height high 5. Like this is how like the winning match would look like. So this is height 3, 1, 2 and 3. And you can see like 1, 2, 3, 4. We need 8 people here. And that's essentially the idea. First person can never win any match. Second person can win 1 match against P1. Third person can also win 1 match because like the binary tree would be more like this. Like only 2 people are there. Fourth person can win 2 matches because like he can have a binary tree like this. Where let's say here P1, P2 play. Here P3, P4 play. Here P3, P4. In this match, P4 has highest score, so P4 wins. Here P2 has highest score, so P2 wins. And now among P2 and P4, P4 has a highest score, so P4 wins. And essentially that's the idea. In sorted order, like number of wins looks like this: 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 3, 3, and the last win would be 4. And essentially that's the answer. So what we can do is like we can sort all the numbers, and then we can see like how many matches someone has won. So like I have looked like for someone to win at least one match, or probably we can put it like this. If someone score is more than one, they win definitely one match. If someone score is more than three, index is more than three, they definitely win two matches. For 7, they will definitely win 3 matches. For 15, they will definitely win 4 matches. Now I read all the numbers as input, and then I also sort all the indexes here. And then in the sorted order from J to N, I see like for a person X, like what was its index. If their index is more than like let's say 7, then we know the person has definitely won 3 matches. And like this is the solution for this problem. Any questions on this one? Like it was kind of just observing how many someone can win and what in what order they should win. Probably if there are no questions on the first 3 problems, then I will move on to D1 problem. Okay, moving on to the next problem. Yeah, move. You are given an array of length n where each element represents an empty ground where ai is equal to 0, or a wall, a positive integer indicating the height of the wall. You can place a ball on an empty ground, that is choose an index I where ai equal to 0 and push it either to the right or to the left. When the ball hits a wall, its height it decreases the height of the wall it hit by 1, then bounces back in the opposite direction. If the ball's height reaches 0, it becomes empty ground. The ball continues to move until it goes out of the bounds. Determine the number of ways to push the ball so that all the balls are destroyed. Two ways are considered different if the starting index of the ball or the direction of the push is different. Some examples are given here as well. Like let's probably look at one of the working example. Let's say these are the coordinate points we have. Here we have a tower of height 2. Here we have a tower of height 3. And here also we have a tower of height 3. And let's say we start from here and the first push it on right side. So the first time ball hits here, this one floor removes and it becomes tower of height 2. And now ball goes back. First time it will hit this tower, this 2 will become 1. And now ball will start moving on this direction. So far like the heights, new heights are 3, 1, 2. And ball is moving in this direction. Then you see like ball will move this 2 will become 1, ball will return back, it will hit here, this 1 will become 0, and ball will go on this side again. So the new height here we have is like 3 0, it's no longer a tower, this is 1, ball is moving on this side. Now ball moves here, like this 1 becomes 0 and ball turns back, hits here, this 3 becomes 2 and ball goes back, and now it will go just outside here. And in the end we will have one tower of height 2 and everything is 0 and the ball goes out of the bounds here. And now we cannot reduce the height of this problem. And this is how the ball is moving. The problem statement asks us like find all the possible starting indexes and all the possible directions in which you can send a ball in the starting direction, so that at the end of the day all the towers have a height 0. And any questions on the problem statement before we jump on to the solution? Okay, so the idea I had was like let's say we start. Okay, what it's saying is like we have some different towers with different heights. You have to count, like let's say we have chosen this as a starting index and this is the direction balls are moving. So the first time like ball will move in this direction, it will hit a tower of height 3, and now the height of tower will reduce by 1 and direction of ball would be changed. So after hitting ball, like this tower has height 2 and ball is moving in this direction. Then it will find this tower of height 2. It will reduce its height by 1. New height is 1 and it will move in right direction. This time here you see like tower has height 2. It will hit this tower. This 2 will become height 1 and ball will again move back. This will hit this tower of height 1 again. This one will reduce to height 0 and then ball will move on this side. And now it was of height 1. Once the ball hits, it becomes height 0 and ball moves back. It founds this tower of height 3. This 3 becomes 2 and then ball moves right and it completely keeps going on the right. So at the end of the day, we would have one tower of height 2 and this is not the desirable configuration we have. So there are few observations we have. Like let's say we are standing here and we want to move in this direction. And the idea is like, let's count the sum of heights of all the towers on this side and sum of heights of all the towers on this side. Let this be C1, let this be C2. And like essentially like this is the number of times we will have to hit here and this is the number of times we will have to hit tower on this side. And let's see what happens at the end of the day. Either it keeps moving like this and the ball ends on this direction. In this case, you will see like the tower was hit once here, once here, once here, once here, and once here. Or what we can say is like if we have hit some tower x times here, we would hit some tower with x times here as well. Because like this is the time when tower last movement is when ball just goes outside. So if sum of height, sum of number of times we want to hit on the left side and right side are equal, and we are moving on right side, it's always possible. Even the alternative also holds true. If sum of numbers on the left side and right side are equal, and if we move to the left side, then we will keep moving it like this, like this, like this, and we will end at the original direction we have. So this is a valid configuration. One possible way in this can happen is first hit here, second hit here, third hit here, fourth hit here, fifth hit here, and then it keeps moving. In this case, this is the first hit. This is first hit on this side. This is first hit, second hit on this side. This is the third hit. So if we hit here x sides, here we will have to hit x plus 1. And like these are the only two combinations we have. If you are moving on right side, then your right side, if left side has x heights, then here either you can have sum of height as x or x plus 1. Or if you start in this direction and number of sum of heights on left side is x, then on right side you can either have x or x plus 1 as sum of heights. And like this was the observation for this problem. Any questions on this one? So what I did was like just maintain like sum of heights on right side, and like basically maintain sum of heights on the left side, answer plus plus, keep adding it, and if x is greater than 0, we cannot start there. Now we know like sum of heights on the left side, and like we know that total sum is s, then we can also find, looking at this difference, we can find sum of heights on the right side. So if we want to go to the right side, if we want to go this side, then this side we can have one extra tower here. So like basically right sum should be greater than equal to left sum, and right sum one extra can be there, so left sum should be less than equal to this plus one, and this is the condition for that. And similar condition we have for the other side, like if we want to go to the left side, so if we hit x times here, we can have x minus 1 or x hits here, and like that's the idea. Or probably the other way to look at it would be, this is one valid scenario where on the right hand side we have x number of elements, then on the left hand side we can either have x or x plus 1 element. This case belongs when we want to move right. And another case can be when left and right are equal, or left side plus 1 is equal to right side. And these were the only two solutions we had. Basically the idea was to see like by looking at what is the sum of heights on both the sides, I can find how many times I will have to hit those towers with the balls. Let's say this side has total sum of, like let's just assume we have only one tower. This side tower has height 5, this side tower has height 7. Then my claim is if you start this side and if you keep going, once this tower goes down, height here would be 0, height here would be 2, and you would be moving on this direction. Once you hit here, this 2 will also become 1, and when you move on the left hand side, you will keep moving on the left side. You won't be able to reduce the 0. Basically, if you have two towers, one of height 5, one of height 7, you won't be able to make both of them of height 0. Similarly, if both of them have height 6, it does not matter on which side you start. If you go this side, you will keep going it like this, and both of them would reduce to 0 at one point of time, and you will move back. Otherwise, if this has height 6, this has height 5, then if you start hitting 6 first, after the first hit, both of them have height 5 and one of them is moving on the other side. So now both of them after the other can reduce to 0 and we can move outside there. And essentially that was the solution for this problem. We don't really need a prefix sum here. Like you can just keep maintaining, like you iterate from first index, you can keep going here. And you can also maintain like what is the sum of height of all the towers I have seen one after the other. And this is what the sum of height of towers I have on the left side. So if I note the total sum, I can also take their difference to find sum of heights of towers on the right side. And that is the solution. No, like left equal to 0 and right equal to 0 answer won't be happening. Or wait, it does happens, I think. Yeah, so like if left equal to 0 and right equal to 0, then it's definitely the case that everything is 0. In that case, it does not matter where you start, on which direction you hit, you will reach out of the loop, you will go out of the site, but at the same time, everything would be 0 when you just go out. So if left equal to total sum of all the elements is 0, then the answer is always 2 into n. And otherwise, left and right both can never be 0 together. Like what I'm saying is like we don't really need a prefix, sum, array, etc. here. Like if everything is zero, yeah, like pre equal to post does not work because you can also have a difference of one. Like for example, this is height 2, this is height 3. You start from here, you go this side, this will become 2, you will move back on this side. You will hit here, this will become 1, then you will revert back, this 2 will again become 1, then you will hit here, this 1 will become 0, and you when you move back, this 1 will also become 0, and then now you can keep going on the whatever direction you go. So 2 and 3 also works here. So not just pre, not like pre I equal to post I, like that's not the only condition. There are cases when pre I plus 1 equal to post I also works, and there are cases when pre I equal to 1 plus post I also works. So like these were the condition. I think I will probably move to the next problem then. The one, zero. So I will probably move to the next problem. Yeah, absolute value of left and right is 1, then also do answer plus 1. Yeah, and if absolute value is 0, do answer plus 2, and that should be enough. It says you are given a permutation n, you are given an integer n. Find a permutation p of integers such that pi is greater than equal to pi plus 1 minus pi minus 1 whole square for every index from 2 to n. It can be proven any solution, at least one solution exists, and multiple solutions exist, print any of them. So like it says, like let's just probably look at some permutation first. Hmm. Permutation is a number which contains all the integers from 1 to n. It says check for each index from I equal to 2 to I equal to 4 if pi is greater than equal to pi minus 1 minus pi plus 1 whole square. So for example, if you want to check for this index, we should check is 3 greater than equal to 4 minus 2 whole square. This is 4 and 3 is not greater than equal to 4. So this is an invalid permutation. Similarly, 1, 4, 3, 5, 2 is a valid permutation. If you look for this 4 is definitely greater than equal to 3 minus 1 whole square, which is 4 both of the time. For this index, like this 3 is definitely greater than equal to 5 minus 4 to the power 1, which is 1 in this case. And this 5 is also definitely greater than equal to 3 minus 2 whole square, which is greater than equal to 1. So like this is one of the valid permutation here. And problem asks us to print any valid permutation here. So any questions on the problem statement first before I jump on to the solution? Yeah, like then like first question is like what is the minimum value of pi minus 1 minus pi plus 1 whole square we can get. Usually like it would always be a positive, and because all the numbers are different, like this difference must be greater than equal to 1, right? So this value pi minus 1 and pi plus 1 whole square will always be greater than equal to 1, because these two numbers are different, so their difference must be greater than 1, and any number which is not equal to 0, if you take it square, it is always greater than 1. So our idea is, and we also know that every permutation number would be greater than equal to 1. So what if we can just create a permutation in such a way that pi minus 1 minus pi plus 1 whole square is 1 for every pair. Then like it does not matter what pi minus what pi is, inequality will hold. And that is what my solution idea over here was. Okay, just start from some index, start filling, like let's say we have this. First start from this number, fill 2 here, fill 3 here, fill 4 here, fill 5 here. Now it does not matter what we have filled on these places, because the difference for any of these number will always be 1. Difference square is always 1, and all the numbers of permutation are greater than equal to 1. So like this is how we should fill the first number, and then we can fill the remaining number like this 6, 7, 8, 9. Now for any number in blue, does not matter what the number is, because if you look at the difference of number nearby, that is also always 1. And essentially that was the solution I had for this problem. Yeah, like basically for even position add all the numbers, and then for odd position. So like start from some number j, for all the odd position one at a time, assign that number j plus plus, and then for all the odd position keep numbers in the sequence and print all the numbers we have got. And yeah, like to answer Sahil questions, guys, when pre equal to stuff answer plus 2, it is because we consider both the direction. We can simply go in any direction and clear all the wall. Yes, that's the correct reason. And the difference 1 is like, now when the difference is 1, we will have to move where the sum of height is more, because we have one extra choice there. And difference of height is more than equal to 2, like we will never be able to make everything 0. So any question on this problem before we move on to the next problem, back and front? So let's see back and front. For the lowercase English letter alpha, let order alpha denote the order of alpha in the alphabet under standard ordering A, B, C up to Z. For example, B is the second character, J is the 10th character, and Z is the 26th character. You are given a string containing n lowercase English letters. You can perform the following two operations on it. Choose a subsequence of string that equals back and delete the subsequence from the string, and choose any pair of character A such that order A has at most 2 divisors, and insert A at the start of S. Note that this operation reduces the length by 3. Choose a subsequence of string that equals front and delete the subsequence from S. Then choose any character A such that order alpha has strictly more than 2 divisors. Append alpha to S. Note that this operation reduces the length of S by 4. You can perform these operations as many times as you like, possibly 0, and in any order. Find the minimum possible length of final string after doing so. And now like we have this. So like this looks slightly tricky, right? Numbers which have at most 2 divisors and numbers which have more than 2 divisors. So like the first thing I did was to figure out what all characters we can insert in each of the operations. So like I counted number of divisors for each number from 1 to 27, and then I counted how many have two divisors and more than two divisors. So like for each character A to Z, if it has two divisors, add it to S2, and if it has at least three divisors, add it to the S3 and print S2 and S3. So you see like these characters have at most two divisors, and you see all the characters B, A, C, K are present over here. So the idea is like when we remove back four characters, we can insert one of the character again so that that can be probably used in the next turn. And similarly, if we look at the number of characters which are more than two divisors, you see all the characters of front are present here, F, R, O, and T, etc. So the idea would be like when we remove a substring equal to front, we would add back one of the character from this. The idea is that now we would be able to use the new character again the next time. And probably to dry run on some example, let's look at this example here. BX ABC. ACF. The idea is like, for example, let's choose these characters first. Like for example, in the first case, we can choose this character. Then like we remove BACK from the original string. And then we can now we can insert any new character here. Any character we want. One, two, three, four, five, six, seven. What is the answer here? Okay, 1 second. BX ABCACFKCK. Okay, I missed a K here. There is one K here. And in the next one, like we can choose any character here. Let's say we have added a B here. Then in the next one, like we can choose these characters BACK. And the idea is that we can remove these characters and any new character again in the starting. And like this was the minimum we say would be present here. And probably let's take some better example. Like this is the original string we have. Hello, hello. Okay, camera should be fine now. The idea here is like, let's say we can choose these four characters in the first row and then insert B back. Now in the next one, what we can do is like we can reuse this B, A, C and K, remove these four characters and then probably insert A back here. And now we won't be able to create any more string. So we would be able to remove 2 back here and like in each turn we would remove 3 characters, so total 6 characters would be removed over here. And like that is how the problem statement is working. Any questions on the problem statement before I try to solve how should we solve this problem? And yes, like I am planning to discuss all the problems for today, so yeah. So the idea here is, let's count how many back we can get, then also count how many ACK we can get, how many CK we can get, and how many K we can get. The idea is, let's say there are 5 bags here. So like we would be able to like basically count how many times we would be able to remove bag from there. The idea is, whatever the total count is, we would multiply it by 3 and like that would be our count. So like when we remove 5 bags in starting, we have 5 possible characters we can add somewhere. And let's say we have 3 ACK here. Yes, DP would be the idea to count how many substrings of bag etc. would be there. Now when we have 3 ACK, the idea is we use one of the B from here, add B, remove the complete string, so that we would get one more character back over here. And like we can keep doing it, like when we have ACK and we have at least one character we can add, we add one B, we remove the same B again, so that we keep on having one extra condition upon there. And like that would be the idea. So like we would also be able to remove these three ACK. Total 8 operations we would be able to do, and we would need 3 Bs for ACK here, and so we still have 5 extra characters with us. Now the next greedy thing we would do is, we will add BA for all these characters of type this, and let's say we have 2 characters of this type. So we have 5 characters in starting, which we can probably add somewhere. What we will do is, like we will add 2 BA, remove that back, so we got one extra character back, which we can probably add later here. So this will end up wasting, like we initially had 5 characters we can place somewhere. To make 2 CK to back, we would have to get away with 3 characters here, and now we have 3 extra characters left. And the idea here would be, like we can keep adding B, A, C, etc. how many times we want, and we would keep getting one character here. So for example, for if we have 1K, we add BAC there. This 3 extra character would remain 0 and we would get one character back. And essentially that's the idea. 2-part solution. First, how many bags exist and how many ACK exist, which does not include the character we have taken here. How many CK exist, how many K exist, and how many empty strings exist. For that, the idea would be to do DP. Like let's say we go up to index I. At ith index, we have count of all the characters, how many back we got, how many ACK we got, how many CK we got, how many CK we got. And say the next character here is C. So what is our choice? What we can do is, like we can add this C to one of the K here to make it a CK. Like when we got one C, what we greedily try to do is, like among all the characters we have, how many of the, like we can take one of them and we can make it ACK. Like we can probably use DP, or we can literally maintain strings as well. That should be fine too. So this is what we would need in the first place, and then it would be greedy. First try to remove all back, then try to remove all ACK, then try to remove all CK, and then try to remove all K, so that we can keep adding all the numbers in starting. Similarly for front, like for front we are adding characters at the back. So like we would again, like we can just revert the string, and instead of maintaining front, we can create a string like this. And then now we can say like we reverse the string and we say instead of adding it at the back, we would add it at the end. And this is the target string we want to remove here. And like that was my idea over here. So like first, like my max remove says how many characters I would be able to remove. If front is the string I want to remove, and I will add new characters at the end. Then I reverse the string and I see like if I can remove C, A, B all the time, and I would add new characters at the back. What is the maximum number of characters I can remove due to this? And its starting character was size of n. So this would be my answer. Now to count the characters, how many I can remove? I look at current length of t which I have. I say like I have infinitely many starting strings of length 0. For each character in S, I see if that character is equal to some character j. Then I pick the string which has j characters so far. It's 0 based indexing, right? It's 0 based indexing, so ti minus 1 would be the jth character. If dpj minus 1 is greater than 0, I say like I have removed one string of length j minus 1 and I have added a new string of length j. And at last, if I did not add any string which is complete length, then I won't be able to do any operation at all. So just simply return 0, you won't be able to remove any character. Otherwise, we can remove all the characters which have complete length. We can remove all the characters which have one less length. And for this character, we would remove one character and add it back, and we can keep going it. And this would be the extra characters we have. Now all the characters which have length m minus 2 up to 0. If we do not have any new character which we can append somewhere, just break here. Like ideally this should not happen, but yeah. Now what is the extra number of characters we would need over here? The idea is like we need m minus k character, and then we would also get 1 plus 1 for removing that character again. So effectively this would be the change if we want to, if we look at current string and we try to make it the complete string by removing. So the number of times we can make such an operation would be c divided by what number of characters are required and how many strings of length k we already have. So we add that count to the answer and we remove those many characters to the answer. There is one corner case here. Like for example, if this is the only string, we cannot say that we would add b before and then remove it. We have to first remove it and then add the character b. We cannot say like we would first remove one, add one character and then remove the other character. So like that is the case when like if we only had less than required number of characters, we just decrease answer by 1 and count by 2 and break over there. And at last, how many times we were able to remove the complete string? That length minus 1 would be the number of characters we would be able to remove. So this was the idea at least. Any questions on this one before we probably jump on to the next problem? Like I'm not sure if this can be done using try. Like at least the code I had was quite small. So probably I will jump on to the next problem then. Connect the chains. It's a chain of length m is a graph of m vertices such that only edges are of form I up to I plus 1 for each I of this one. You are given n chain groups, each of length n. The jth vertex of ith chain has an integer aij written on it. You would like to merge all these chains into a single tree of n into m vertices by adding n minus 1 extra edges. What is the minimum possible number of such a diameter? The diameter of a tree is maximum possible sum of values on a path containing two vertices of a tree. Formally, for two vertices u and v, f of u comma v denotes sum of values of all the vertices that lie on unique path from u to v. The diameter of tree is maximum value of f of u comma v for all the pair of vertices. Probably a slightly standard definition, but in case of tree, what we know is like it's the maximum distance. Like, okay, how does adding reverse of back to and is similar to adding back to front? Like the idea is, if you look at the original string, you remove back and add some character to the back. Or if you look from this side, then you would have to remove the reverse of back and you are only adding character at the back side. Like, see what is happening here. You have one original string and you are looking it in the mirror. If you remove B A C K from here, on the mirror, inside mirror, KCAB is getting removed. And when you add something in the starting, on the mirror side, something at the back is getting added. That is why it's equal, like similar to the original problem. Let's probably just draw a diagram here. Like for this graph. Like for example, you have this. It says we have one chain which looks like this. And we have one more chain which looks like this. We have to add one more vertex here such that the diameter is minimum possible. Now see what are the combinations we have. If we add a new length here, then this path would have the maximum length and the answer here would be 6. The length 10 we would get. Like it said less than equal to 2 divisors, not exactly 2 divisors. And A has just one divisor, so that's fine. Or if we add a edge between these two, then this would be the maximum path of length 9. This path would be of length 8 and 9 is maximum. And in the optimal answer, the problem statement says like we should add a length here. So like here, like the maximum path would be of this between any two pair of vertex, which is of length 3 to 8 and 8 was the answer here. Like if we add a chain like this, probably let me just remove all the. Now if you look any pair of vertex, you can't get more than 8 as a sum over here, and that is how the diameter is defined. Or probably I can take one more example. We have this diameter 1, 2, 1. These are connected. We also have 4, 3, 3. And we also have 1, 1, 1. And here the idea would be like, let's connect these two edges first. And let's also connect this two with this one. This 3, sorry. In this case, the maximum path we can get is 1 is probably this path. So this is of around length 1, 3, 6, 8. Or probably like this is the maximum we have, which is around 10. So the answer for this test case was today. So any questions on the problem statement before I jump onto the solution? No, like it's slightly confusing. It says look at it like a matrix here. This is the first graph where there is an edge from I to 1. This is the second graph you have where there is an edge from I and I plus 1. This is the third graph you have where you have an edge from I to I plus 1 initially. So these are three different graphs you have. And now when it says कि add edge between 1 comma 1 and 2 comma 2, it means take first vertex of the first graph and second vertex of the second graph, add an edge there. And then adding an edge between 2 comma 3 and 3 comma 1 means take the third vertex of the first graph and first vertex of the third graph and join them like this. So total n into m vertices are there. So my idea is probably what I can do is I can first choose the one vertex and I will connect every graph from that vertex. So like this is how like the original graph of this vertex looks like. For every other line graph, I will find the optimal point, one optimal point, such that if you look at this and this, like basically for first every graph first find an optimal point. By optimal point I mean if this is the line graph and if this is the vertex from which I am joining the other vertices, then what would be the maximum distance we will get from this graph? This would be distance d1, this would be distance d2, right? So maximum of d1 comma d2 is minimum possible. The idea here is if let's say like the path we are looking at comes out here of length 6, then here it can go probably let's say 4, it can go probably for 8, then the maximum we would get would be 14. But at the same time if we can shift this graph like this, such that this is 6 and this is also probably let's say 7, then any graph of length 6 which is coming here can go maximum distance of only 7 here. And that is the thing I am trying to do. My claim is like I will fix one vertex and then for every line graph I would connect one of the vertex with that vertex over there. And for that, for every line graph I am first finding the optimal position where I should probably connect it from some other vertex, such that now the two halves we have for that particular line, maximum of them is minimum possible. Because for example you see like let's say if I choose this point, this is of length 4 and this is of length 8, then if any path of length 6 is coming up to here and if it goes up to this side it would travel a 14 distance, while if I shift it slightly so that this path is of length 6 and this path is of length 6, then everything else if same, then if anything of length 6 comes here, the maximum it can go would be 13. Earlier it was going up to 14. That's the first optimization I am doing here. So that's the optimization I am done. So like first thing, like the diameter, like if you look at the single line graph, whatever is the distance from the first to last vertex, you can never remove that by adding any pair of vertices there. So you should definitely take your answer with the max of that. And now like my idea was like for each point, see what is the distance in the same graph, what is the distance in the other graph, and for all the other vertices, what is the maximum distance from the optimal points we have. Some of the graph may have like this. Some of the graph may have like this. So basically just look at the maximum 3 vertices etc. over there. The idea is, let's say this is of distance 10, this is of distance 20, this vertex has 30, this vertex has distance 100, this vertex has distance 200, and like let's say this is 180 and this is 60. So in this case, if you connect this 30 with these two, the maximum distance you can get would be like from 30 go up till 100 here, 130, plus go up to 200 here, it would be 330. And you can never get anything more than that. Like this 30 plus 180 plus 100 would give you around 310 and so on. So that is why for each graph I am first figuring out the optimal point, and then when I fix one vertex and I say like I will connect everything with that vertex. So like look at the maximum two values you can get for of the optimal distance from somewhere. Like let's say probably I also have this one line graph where optimal distance this side is 10, this side is 20. And when I connect it here, the max I can get using this 20 would be 20 plus 30 plus 200, which would be around 250 only. And that this is the idea I had for this problem. Any question on this one? Like first read everything as input, and then for each individual line graph count the sum of length of everything there, and I say like we won't be able to get diameter less than that. And then what I keep doing is like I keep moving one after the other and see like if I pick one point from there, what would be the maximum distance up to right vertex, what is the maximum distance up to the left vertex, and take maximum of both of them and keep taking it minimum. So once you are done with this loop, you know like if you choose an optimal point in this line graph, d would be the maximum distance you would need there. Now basically I have sorted everything in the reverse order, and the very bare minimum I have is like I chose the two line vertices which have maximum distance among them, and like just join them somewhere, and this would be the distance I would be able to get. If n equal to 2, like we have basically tried out everything here. Otherwise now I fix the midpoint from where I would fix everything. So I do the same algorithm here. For each line graph, for each point, LT is the maximum distance on the left hand side in that right graph. RG would be the maximum distance on right hand side of this graph. And this current value was the bare minimum we got without any further observations there. So now like on the left hand side, if the current vertex was the maximum one, then I look at second maximum, third maximum, and I see if I connect them with my current vertex X, this would be the distance I would get. And like second maximum, and if I go to any path on the same line graph here, this would be the distance I would get. So like if X is my current vertex, then like CS would be the maximum diameter I would get. Take answer with minimum of them. And similar logic is there for if my current line graph had the second maximum distance or the third maximum distance. And at last, whatever minimum answer I got, I ended up printing it. Any questions on this one before we move on to the last problem for today? Okay, binary strings yet again. It says for a zero index binary string s of length n, define f of s as number of pairs I and j, such that I is less than j and si equal to 0 as j is equal to 1. Given a binary string of size n, you can perform following operation exactly once. Choose an integer k such that n mod k is 0 and k must be greater than 1. Divide the string into continuous blocks of size k. That is, you have n by k strings. One goes from 0 to k minus 1 character, k to 2k minus 1 character, up to n minus k to n minus 1 character. Rearrange these n by k strings in any order we want, and then we get a new string by adding all of them back. What is the maximum possible value of f of s we can get after this operation? And then there was some non-trivial way, like string s was not given to you directly, but using some non-trivial way. Like I will probably avoid this discussing on this one. Let's just say we have a binary string of length n. Probably let's take some examples here. Let's say this is the binary string we have, and let's say we want to see what is the maximum score if we choose k equal to 3. So the idea here would be like this is how these strings would be divided. And now you see, however we arrange these strings, like this subpart wherever it goes will have a score of 1 only due to this pair. Similarly, this subpart wherever it goes, it will have a score of 1 only because of this pair. And this subpart will have a score of 2 only. So like 4 is the minimum we would get. And now we can forget about zeros and ones in each pair. What we have to see is like if this comes before this, if this comes before this or this comes after this, doesn't matter, both of them are same. Let's see this. Either the order here would be 0 0 1 1 0 1. In this case the score would be like this character is already counted. So for this one new zeros would be this 2, and for this one new zeros would be these 2. So total 2 cross 2 would be the new score here. While if you look at this 1 0 1 0 0 1, these ones would not have any new zeros before them, and for this one the new one we have got here is only this one. So the new score we have got here is 1 comma 1 only. Or in general, if we say, if we have this piece which is z zeros and k minus z ones, and this piece z1, let's call it z1, this piece has z2 zeros and k minus z2 zeros, then if we add this before, then the new score we would get would be z1 multiplied by k minus z2, number of ones here and number of zeros here. Or other way around, like if we have z2 ones and k minus z2 here, and z1 and k minus z1 here, the number of ones extra pairs we would get would be this z2 and k minus z1. If we expand them a bit, the new score because of this configuration would be k z1 minus z1 z2, and here would be k z2 minus z1 z2. So you see, like any pair which has extra zeros, more zeros should be kept first. Like this is same in both of these. The only difference is because of this. Should be arranged first. And like for 40 points, this is enough solution we have. What we can do is like we can take n as input, we can create the original string, and then we can look at every string of zk. Like, let me see if I have. I first created the original string. I found all the factors of this number. Now I iterated on all the factors. And it should also be the factor here. And I see like for each segment how many zeros and ones are there. Count zeros. If a 1 comes in, whatever the number of zeros we have in this segment so far, that would definitely be the score in this segment irrespective of where this place. So add this count to your current score. Otherwise, if you got 0, add 0 plus plus and b dot implies back 0. Now sort like reverse sort in the descending order. The ones which have maximum zeros should come forward. Now in the increasing order, before the current segment, I have total 0 zeros. On the first segment, I see like if this has z zeros, then k minus z ones should be there. And how many zeros I have got before. Add that to the answer. And then 0 plus 1, like basically now place the current segment here. Keep doing it for all the iterations. You would get the final score, and that is the maximum you can get by any arrangement here. We have tried out all the possible k values here. And for each k, we have greedily tried to make as many 0, 1 as we want. The problem for 100 subtask points becomes a bit tricky, like it's kind of constant factor optimization. Sum of n is up to 47, and we cannot just try out all the factors here. So one critical observation here was we don't really need all the factors here. We just need prime factors. Because you see, if you are processing for k equal to let's say 12, then that even 12 length strings can be broken into more strings of length 333 each, or 6 strings of length 2 each. And if you want a pair of length 12 to be together, you can also keep that pair together when you are looking at length of 2. So that was the first optimization I had. Okay, keep only prime factors of the number here. We don't need all the factors. And the another optimization it was like, let's say we have number of 4e10 and 2 is a factor. Then if we sort numbers of, like, we would have to sort 2 into 10 to the power 7 numbers, and it will get a TLE. But you see, if you have looking at k equal to 2, number of zeros can be 0, 1 and 2 only. So the idea was to use frequency, like what is the name, like counting sort instead of merge sort here. So created a counting sort here, like the same algorithm. And like instead of generating the complete string s in the starting, now I am looking at 1 bit at a time when I am processing here. Like the same algorithm, count if 1 exists, add the number of zeros in the current segment, and some changes here, and b plus plus. Now iterate on the decreasing order of the count from k up to 0. Let f be the number of zeros, a while loop f minus minus where we have z zeros. Add score due to one of them and 0 plus z, and this ended up giving me full solutions here. Like probably ideally I expected it should fail, like for example we have a prime number of digits 6, 7, something like that. Getting that large vector here might be a problem here, but this ended up passing the test cases. So my first solution was to use like the previous solution where we sort if we have more than let's say 7,000 element. So that 4 into 10 to the power 7 by 4th 7,000 element would be some 1e4 or so, and their sorting would not get a TLE. And if we have less than let's say 7,000 elements, they use this counting sort. So this array is of size small as well. And that was the optimization I had, but looks like it wasn't really required. So any questions on this problem or any other problem? Probably not a fan of this problem. Like it was more of a constant factor optimization than anything else. And I think I am pretty much done discussing all the problems unless some people have few questions in the chat. No, like you can't see your failed test case when the contest is running. Like where do you see? Okay, the details of failed test case visible on your solution page means like you would be able to know how many test cases you are passing, not what test case you are failing. So for example, when you submit, like when I submitted, I knew how many test cases I passed and how many. Okay, probably just to brief it, last problem into short. The idea is we should only take all the prime factor k of n, because like anything larger than that can be broken into a subproblem for prime factors. And number of prime factors up to 4e, 7 are just 9, 10 only. And then when we look at the a particular value of k, we should count how many 0, 1 pairs we would get within that segment before rearranging, like just that segment, how many zero pairs, add that to the answer. And then now look at all the segments. And the idea is the segment which has more number of zeros should come first, and the segment which has more number of ones should go last. So you can probably arrange those segment in the decreasing order of number of zeros or the increasing order of number of ones. Both of them are same thing. And now for that configuration count, what would be the score we get from over there? And like essentially that was the solution. That idea essentially pretty much solves the first subtask. For second subtask, what I did was instead of sorting all the segments with number of zeros, I ended up using counting sort algorithm to sort the numbers there. So yeah, just three things, not just, but three things I had. And any more questions in the chat before we call it a day? And thanks everyone for joining today.